Hello, I'm Uma. I'm the co-founder and CEO of Succinct, and today I'm excited to be telling you about what we're building with SP1, our ZK VM, and also ZK applications that we can build both inside blockchains and outside. So let's start off with a brief overview of what is a ZK proof. It's probably a concept that a lot of you guys are familiar with, or maybe some of you have heard it thrown around for a long time. And ZK has historically been something that is super complex and not understandable by many, but I actually think it's a really simple idea. At its core, ZK is a cryptographic primitive that allows one party, the prover, to prove to another party that a statement is true without revealing any additional information. So the prover can prove that a computation, when applied to a certain set of inputs, results in a certain output, and the verifier verifies the proof, and they don't have to re-execute the computation, which is the succinctness property. And there's also the zero knowledge property, where some of the inputs optionally can be hidden. And ZK is useful for the succinctness property for scaling blockchains, and the zero knowledge property is useful for privacy on blockchains, which come as public ledgers by default. So at Succinct, we're building SP1, our ZK VM, and our goal with Succinct is to make ZK much more accessible to all builders. So as I was mentioning previously, ZK has been around for a long time, but it's been very, very difficult to actually build with it. So on the left-hand side, you can see the old way of doing ZK, known as writing circuits, where you have to write in obscure languages or DSLs. It looks very odd. It doesn't look like a normal programming language. And maybe hundreds of people in the world maximum could actually use ZK in this way. With Succinct and our ZK virtual machine that we built, ZKVM for short, you can just write normal code. So you can take Rust, write normal code, and then you can generate a proof with SP1. And what makes it possible now for millions of developers who are Rust developers or really any other programming language that compiles to RISC-V to use ZK. So it's really exciting because now ZK is much more accessible, and the types of statements you can prove with ZK become much more complex and expressive because you can just prove all kinds of software. SP1 is also pretty special, not only for making ZK much easier, but also making ZK a lot faster and more performant. So this chart shows SP1's performance from when we launched it around a year ago to now. And you can see since then, we've improved its performance by between 20 to 50x, depending on how you measure it. And that's thanks to better algorithms and better cryptography, better GPU utilization, a bunch of engineering, and a lot of hard work on our team. And performance is super important because if we're trying to scale blockchains, we need to be able to generate ZK proofs for cheap so that user transactions can actually also be cheap even when they're using ZK. And then the final piece of the puzzle that ties everything together is our protocol, the Succinct network. And what the Succinct network is it's a protocol where applications who use ZK, whether it's L2s, rollups, bridges, oracles, identity protocols, who are using SP1 can send proof requests to the network and then have proofs generated by provers in the network who are running specialized infrastructure to actually generate these proofs. So as the previous talk was mentioning, if you want to use a ZK VM and you want to generate a proof on your laptop, that's not really going to work because generating a ZK proof is pretty computationally expensive, requires GPUs today and possibly FPGAs and ASICs, which are custom hardware in the future. And so you need specialized provers running in data centers all across the world to actually generate these proofs. And that's exactly what the Succinct network is. It makes it easy for anyone to send a request to the network asking for a proof. It makes it easy for anyone to generate the proof for a competitive price. And it coordinates these actors, the users and the provers, and does transactions and pricing between them, and also sets up an auction system to make pricing competitive. And our vision for the network is that it's going to have this global distributed hardware build-out where you have people all across the world, similar to kind of participation in Bitcoin mining, who are mining ZK proofs and making ZK proving fast, easy, and cheap. So I like to say that SP1 and the Succinct network results in ZK 2.0, where you have this old paradigm of ZK, ZK 1.0 on the left-hand side, where you can see that it was very, very difficult to use. And teams had to have dozens of PhDs and cryptographers and engineers devoted to making their own proof system and their own prover for their specific use case. So often these use cases were ZK EVM rollups, like many of the ones that you have probably seen and heard about. But with SP1 and the Succinct Prover Network, now the types of applications you can build are 100x broader, because you can just write normal code or take existing pieces of software and write provable programs with them. And it's also a lot more efficient to get to market, because you don't have to set up your own proving infrastructure, your own prover stack. You can just deploy it to the network and get proofs from that. So overall, in this new paradigm of ZK, it's general purpose, so you can prove a lot more stuff. It's fast, it's easy, and I think this is also the reason this year we're going to see kind of an explosion in ZK adoption and also the use cases. So first I'm going to talk about what ZK 2.0 in this paradigm can enable within blockchains, because we are at a crypto conference. And so I think the biggest thing that people in this audience probably already know is that ZK is useful for blockchain scaling, whether it's ZK rollups or ZK chains. And the fundamental intuition behind why this is true is that in blockchains you have decentralization. And decentralization has an inherent overhead because you have a lot of nodes in the world who are engaging in redundant computation. They're re-executing all the transactions in the network to validate the state. But with ZK's succinctness property, we can fix this inefficiency and make it so that blockchains have unlimited scale. You have one person who generates a ZK proof of a bunch of transactions executing, and then you can have millions of nodes or, one day billions of nodes in the world verifying those proofs and scaling the chain and verifying the chain, so you don't sacrifice decentralization or verifiability with the ZK succinctness property. And I think it's very well known that Ethereum's scaling roadmap is very centered around ZK, right? You have ZK rollups, ZK EVMs. It's been mentioned in many Vitalik blog posts for many years. But actually, I think something that's not as well understood is that ZK is applicable for many ecosystems. So we have many teams building on Succinct and the Succinct network who are building Bitcoin rollups and Celestia rollups, and also even Solana network extensions, which is kind of their rollup and scaling roadmap. And so it's exciting to see that verifiable TPS, basically transactions that are secured and scaled by ZK, is generally going up even beyond Ethereum to all these other ecosystems. I think another interesting thing to point out is ZK's role as the end game of security and verifiability within blockchains. So if you think about kind of the transition we had from mining to staking, right? In the past, if you wanted a decentralized verifiable chain, your options were proof of work mining, which was very wasteful and lots of redundant computation to come to consensus. Then we moved to proof of stake, where you have all these validators kind of voting and coming to consensus. But that's actually pretty expensive if you have to pay your validators a lot of emissions to actually participate in the chain. And it's annoying to coordinate a bunch of entities who are validating the network and coordinate them on network upgrades and stuff. And now with the rollup-centric roadmap, the architecture is really nice. You can post your data to a consensus layer or a data availability layer, for example, Ethereum, but now there's other options like Celestia, EigenDA, or even some people are trying to use Bitcoin for DA. So you have consensus on transaction ordering, and then you get the unbounded scale and verifiability and interoperability with the ZK proof of what all those transactions are doing and applying the state transition function to them. And it's actually a really interesting statistic of how much these networks are actually today paying for the economic security from staking. So this chart shows that the top networks are often paying billions or hundreds of millions of dollars for economic security. And you can imagine that if they use a scalable DA layer, something like Celestia or EigenDA, and then use ZK on top, all that money that they're paying for staking could actually go towards paying for proving. But proving is actually a fraction of the cost. And so I argue that ZK makes verifiability and security 10x better and 10x cheaper than staking, and is kind of the endgame architecture for all these networks in the future. Another way to view the market size for ZK for scaling is doing some back-of-the-envelope math on how many verifiable transactions we're going to have in the future. So today, I believe Ethereum and all its rollups does a couple hundred TPS. But imagine that the market for rollups scales to that of a Solana level TPS, which is around 4,000. If you imagine that every transaction pays 1/10 of a cent for proving, then if you crunch out the numbers at around 4,700 TPS, that's $150 million a year in revenue devoted to proving. You can also imagine a scenario in which each transaction pays 1/100th of a cent for proving, and we scale 10x beyond our current throughput demands for blockchains to 40,000 TPS, and you end up with a similar number. And these TPS trends are up only. Transactions on L2s have 15x over the past 5 years, and transactions on Solana have 10x as well. So hopefully this is kind of convincing that as we see verifiable TPS and demand for blockchains growing, we'll also see kind of the demand for proving growing as well. And then the final thing I want to touch on the theme of ZK for blockchain scaling is that often people think ZK for blockchain scaling only means ZK EVMs or ZK rollups. I actually think that there's a really broad category of applications that go beyond just ZK EVMs. So in particular, if you look at the EVM today, the EVM actually has a lot of overhead and poor design patterns for very high throughput specialized applications. And you can imagine that now we've realized the end game paradigm for verifiability is these RISC-V ZK VMs where you just write normal code and then you can prove it. For really large-scale specialized applications, you can just write your logic in normal Rust code, for example, verifiable exchange or verifiable perpdex, and then you just directly prove it in a ZK VM and you settle to some base layer. And so this paradigm of verifiable applications is something that we're going to be talking about more in the future, and something I'm excited about to see verifiable applications beyond just ZK EVM rollups for scaling blockchain use cases. And then the last thing I want to touch on is OP Succinct. So I've kind of hopefully given the argument that chains are going to be rollups. It's more efficient than having to bootstrap a proof of stake network. I've also talked about rollups can come in many forms. You can have ZK EVMs, but you can also have verifiable applications. And then I'm going to talk about today what we're actually seeing in production. So the biggest use case today that we see for Succinct is OP Succinct, which is basically taking an existing rollup stack on Ethereum, OP stack, combining it with SP1 and the Succinct network, and making it very, very easy to deploy a production-grade ZK rollup. So you get a one-click upgrade to a ZK rollup, you get to leverage an existing battle-tested rollup stack, and you get, as a rollup, you get 1 hour finality, which is 100x better than the 7-day finality you experience with OP stack, and better security. So this trend, I think, kind of proves my point that every rollup will be a ZK rollup, and also that ZK 2.0 can upgrade existing infrastructure that exists, like the OP stack, very seamlessly. And OP Succinct actually has adoption even today, even though it was released only a few months ago. So we've been running a mainnet since January, and we have another customer, Mantle, who is using it on their testnet and planning to go live on their mainnet with it soon. And they're a very large rollup with over $2 billion in TVL. So it kind of shows these existing trends are already playing out. So hopefully, at this point, I've kind of convinced you through OP Succinct and all the other charts that ZK's impact on blockchain scaling is going to be very, very important to the story of blockchain scaling, and also a very big market. But I think one thing I'm really excited about that gets less attention is ZK's impact outside of blockchains. And those are the use cases I'm going to talk about next. So let's look at some use cases outside of blockchains that can benefit from ZK's verifiability and also privacy-preserving properties. And let's go through a few practical examples. So today, if you have any use case in the real world where you want to prove to someone some information about yourself or patterns about things you've done in the past, you often have to reveal a lot of information. So for example, take a rental agreement. Today, at least in America, if you want to rent a house, you have to usually provide your entire bank statement and income history to prove to your landlord that you have enough funds to cover the rent. In a world with ZK, you could imagine instead providing a ZK proof of meeting your landlord's income requirements without revealing anything extra, which is a huge breakthrough in preserving privacy and keeping your identity credentials to yourself. In a similar example, today, if you want to prove your nationality or you want to prove, your age at a bar, you often have to prove your entire driver's license information or your passport in clear text. But with ZK, there's actually a few protocols coming out, ZK email, ZK passport, and several others, where you can just generate proofs of your passport credential or your driver's license credential, and then selectively reveal or open the fields that you want. So you can say, I have a driver's license issued by the state of California that has an age that's over 18 without revealing your exact birth date or address or anything else. And then finally, the last use case, maybe a little more crypto native, is that today if you want to prove you have an address in a set to claim an airdrop, or prove you have a certain Twitter account to claim an airdrop, you have to dox your particular account to the protocol to be able to receive, your airdrop claim or tokens or NFT mint or whatever else you want. But with ZK, you can actually provide a membership inclusion proof saying, I have ownership of an account in this set, and prove you belong to the set without revealing your specific identity. So you don't have to tie your identity to your on-chain address, and you preserve privacy. And there's this broader theme of self-sovereign identity with ZK, where you can keep your identity to yourself and selectively reveal or open facets of it that you want to someone else when you want with ZK proofs. And as I was mentioning, there's actually a few protocols who have popped up recently that are doing these exact sorts of things. So one is ZK email, where basically you can prove you have ownership over a certain email account with a certain domain, or you received an email from a certain provider. So for example, you can prove you have a Robinhood account, or you prove you have a Coinbase account, or prove you took a bunch of Uber rides for proof of humanity. And then there's a protocol called Self Protocol that lets you prove passport credentials and nationality credentials, which is really interesting in a bunch of different on-chain contexts. And there's a bunch of others that I'm not mentioning, but I'm really excited to see the rise of these ZK identity protocols to take ZK's impact beyond just blockchain scaling. The other category I'm also interested in beyond ZK identity is kind of helping remove trust from existing institutions or regulators and making it verifiable. So one example that I think is very interesting is today, if you look at credit scoring agencies, there's actually a lot of trust placed on these companies. They are trusted to run unbiased algorithms to determine your credit score, which is actually very important because it determines things like your interest rate on your mortgage loan and things like that. And there's these trust assumptions that are weakly enforced through government regulation. But imagine in the future that credit agencies were required to do verifiable machine learning with something like ZKML to show that their algorithms are provably fair. And when they run their algorithm and give you a credit score, they also provide a proof that the algorithm was the particular algorithm that we've all agreed on satisfies the properties we want. Similarly, with insurance providers, healthcare providers or otherwise, they can run today, you have to provide your entire insurance history to them, and they run trusted algorithms on your private data to determine your premiums. But really, they're running these algorithms on data that's not meant to be their own. It's really your data. So in a ZK future, you could imagine that you keep your data private, and you generate a proof of the algorithm they want you to run, and then you get a provable premium from them, and you're able to prove computation on your private data and keep your data client side. And then the last use case that I think is really interesting of removing trust and making things more verifiable is that especially with the rise of AI, today it's nearly impossible to verify what is a real image or not on social media. It's impossible to tell if the image came from an actual journalist with a real camera or something that's from Midjourney. And one way you can use ZK to combat this problem is you can show image provenance from a real camera that has an attested hardware sensor and show that there's a set of ZK verifiable transformations applied to that image to prove the image's authenticity from a real camera source. And you can also do this for other forms of media like voice or video, which I find really interesting. And actually at a hackathon, someone built this last use case. They built a very cool POC attested image editor with SP1 where you have something that's Photoshop-like in the browser, where each image edit also generates a ZK proof that it's a valid image transformation. And at the end, you get a proof that's strung together of all the transformations you've done to prove that the image came from a real camera. And that's only possible due to something like SP1, because before, if you tried to have the JPEG compression algorithm or really cropping or rotating or a Gaussian filter implemented in a ZK proof, it'd be very, very impossible to code all of that logic in a circuit. But today, you can just take a Rust image library, stick it in SP1, and then you can make a hackathon project that does this attest and image editing thing in a weekend, which I think is really awesome. So the moral of the story is that with SP1 and the Succinct network, ZK 2.0 is here. You can build anything you want. You just write normal code. It's fast, it's easy, it's cheap. And ZK is going to have a huge impact in blockchain scaling, which probably most people here already know about. But it's also going to have a huge impact even outside of blockchains and all these cool use cases of self-sovereign identity, verifiable images, and removing trust from institutions. And I think it's a very exciting time to be building in ZK. And so if you're building with ZK, use SP1, reach out. And I'm excited to see all the things people end up proving. Thank you.